Hi, I'm Sarah.
And I'm August, and we did our project on a 3D printed archery prosthesis.
August and I both knew we wanted to do a hands-on project with a focus on engineering and medicine. My mom is an amputee and had asked me if I could find a way to make a more permanent shoulder pad for her while I was taking the Maker Lab elective last year. This led to an interest in prosthetics that guided the direction of our capstone. Growing up, trying new sports was an important part of our childhoods, and kids with limb differences often don't get to experience this.
Conventionally manufactured sports prostheses can range from $5,000 to $50,000, and they typically only last 3 to 5 years, meaning that over a lifetime, someone with a limb difference can expect to spend hundreds of thousands on prosthetic devices just to continue playing their sport. This high cost also makes trying new sports difficult due to the high cost of entry. Kids also often have to replace prostheses more often as they outgrow their old ones. So 3D printing brings this cost down to less than $500 and allows for greater customization and redesigning as the kid grows.
Mr. Walter introduced us to Sammy, a 9-year-old boy with an upper limb difference. Sammy told us that he likes to do archery, but found that the bow rubbed against his skin and made it difficult to shoot for a longer period of time. From there, we decided our problem statement would be, Sammy needs a way to do archery without hurting his hand because his limb difference should not prevent him from pursuing his passions.
We started off by meeting with Sammy to learn more about what he could do versus what he wanted to be able to do, and to take measurements of his arms so that we could begin working on a design. Additionally, we used a spring scale to measure Sammy's strength so that we could understand how much force our prosthesis needed to withstand.
We then came up with a couple of sketches of possible designs before moving into a cardboard model fit to August's hand. From that model, we designed and printed a brace and glued it to an arm strap to create a base that we could attach a release to.
We then used Fusion 360 to design a set of bars that could be sewn into the arm straps and then screwed into the brace. This allowed for the brace to be redesigned and replaced as many times as we wanted without having to resew the straps every single time. From there, we created a space for the release to sit on the brace and connect with a cable. As you can see in the third image, we originally put the release across the brace at an angle, but this caused issues with the bow not releasing because the string would catch on the side of the release and not let the string go. So we changed it to sit on the side, which you can see in the fourth picture.
Our latest prosthesis model included a brace which is screwed into the arm straps and has the release mechanism attached to it. The release mechanism itself has a hole drilled into the lever in which the cable runs through. Our idea was to have Sammy trigger the release mechanism by pulling on the cable on the other end, which is attached to a ring that sits on his pinky finger. Once we had a working prototype, we met with Sammy to test it and get his feedback on the design. Sammy said he liked the design and that it was comfortable. However, we realized that Sammy's pinky was not as strong as we initially measured and did not have the range of motion to be able to pull the cable to trigger the release mechanism. This ultimately led to the finger trigger not working, so we are currently redesigning our prototype to allow Sammy to trigger the release with his foot.
So we had many challenges and setbacks throughout this process. Working on a physical model without being in the same room every day caused our project to take much longer than it otherwise would have. We also could not meet with Sammy as often as we would have liked to, so each time we met, we had to make sure we had multiple solutions ready just in case our first idea didn't work. Additionally, all of our meetings, whether it was just the two of us working together or us meeting with Sammy, had to take place outside, and we had to reschedule meetings on multiple occasions because of snow or rain. So for key takeaways of our project, our main goal was to create a documented process that others can emulate for other sports. By setting this process up in 3 parts, measurements, design, and testing, we created a framework for others to follow in their own projects. Our design can also be put on the internet for others to use and modify. So it's open source and can be improved on by the community, and they can upload their own versions.
Thank you so much for watching, and we hope you enjoyed learning about our project.